Welcome back to Space Repo, your portal to the cosmos. Have you ever wondered what would happen if you fell into a black hole? Hollywood paints a dramatic picture, but the reality, according to physics, is far more bizarre and terrifying. Forget what you've seen in movies. Today, we're taking a journey into the abyss, exploring the chilling truth of what awaits beyond the event horizon. Imagine you're an astronaut, drifting through the silent expanse of space. In the distance, you see it, a region of perfect blackness, a void warping the starlight around it. You've found a stellar mass black hole, a cosmic monster born from the collapse of a massive star. Your curiosity, or perhaps a catastrophic engine failure, has set you on an irreversible course. As you approach, the first major milestone is the photon sphere. This is a region where gravity is so intense that photons, particles of light, are forced into orbit. Light here doesn't travel in a straight line. Instead, it circles the black hole like a moth drawn to a flame. From this vantage point, the universe would look incredibly strange. You'd see multiple images of distant stars and galaxies, warped and distorted by the immense gravitational field. You could even, in theory, see the back of your own head, as light from it travels all the way around the black hole and back to your eyes. But this is just the beginning of your surreal journey. As you drift closer, you cross the point of no return, the event horizon. This isn't a physical barrier you'd crash into. It's an invisible boundary, the ultimate one-way street in the universe. The moment you cross the event horizon, your fate is sealed. No amount of rocket power, no conceivable technology, could ever pull you back out. You are now causally disconnected from the rest of the universe. Nothing you do can ever affect the outside world again. For an observer watching from a safe distance, something very strange happens. Your image appears to slow down as you approach the event horizon. Time itself, for you, seems to stretch and dilate from their perspective. They would see you get redder and dimmer, frozen in time at the edge of the black hole for an eternity. But for you, time feels perfectly normal. You cross the event horizon without any immediate drama, floating onward into the darkness. This is where the true horror begins. The black hole's gravity is not uniform. The part of your body closer to the singularity is pulled much more strongly than the part that is farther away. This differential in gravitational force is known as a tidal force. And it's what will lead to your ultimate demise through a process known as spaghettification. Your body would be stretched, vertically, like a piece of spaghetti. The pull on your feet would be astronomically stronger than the pull on your head. Simultaneously, you would be squeezed from the sides. The process is as inescapable as it is gruesome. Your body would be elongated, thinned, and eventually torn apart, atom by atom. You would become a stream of fundamental particles, spiraling down towards the center. What about time? As you fall deeper, time dilation becomes even more extreme. From your perspective, the entire future of the universe would flash before your eyes. You would witness stars being born and dying, galaxies colliding, and perhaps even the eventual heat death of the universe itself, all in the few moments before your own end. All this time, you are falling toward the heart of the black hole, the singularity. According to our current understanding of physics, the singularity is a point of infinite density where all the mass of the black hole is concentrated. It's a point where space and time cease to exist as we know them. The laws of physics break down completely. What happens when your stream of particles reaches this point? We honestly don't know. General relativity, our best theory of gravity, cannot describe it. Some theories suggest the singularity is a gateway to another universe. Others propose it's a fuzzball of vibrating strings of energy, as suggested by string theory. Perhaps all the information that made you is not destroyed but is instead scrambled and plastered onto the event horizon, a concept known as the holographic principle. But these are just hypotheses at the very edge of our scientific understanding. The true nature of the singularity remains one of the greatest mysteries in all of physics. Your journey, which started with a gentle drift across an invisible line, ends in a place beyond human comprehension, where the concepts of space and time lose all meaning. The experience of falling into a black hole isn't a quick trip through a cosmic tunnel. It's a slow, methodical, and mind-bending deconstruction of reality itself. It's a journey from the familiar into the utterly unknown, governed by the most extreme forces in the cosmos. The reality of black holes is a stark reminder of how much we have yet to learn about our universe. They are not just cosmic vacuum cleaners, but laboratories of extreme physics that challenge our most fundamental theories. So the next time you look up at the night sky, remember that hidden in the darkness are these incredible objects, where the rules of our world are completely rewritten. Thanks for joining us on this journey into the abyss. If you found this exploration as fascinating as we did, be sure to subscribe to Space Repo for more deep dives into the cosmos.